Welcome back, students and others who happen to find this video. Let's take a look at visualization of data in dplyr. dplyr is one of the core packages of the tidyverse ecosystem in R. And I'm going to say it kicks trash with visualizing data, meaning it's awesome. It's the cat's pajamas, the bee's knees, whatever term you want to use, it's that for visualizing data. Now, if you disagree and you want to leave a respectful comment in the comments below this video, go for it. I am always up for learning. But anyway, we're going to look at gglot2 in R. Here are the basics. We need some data, right? Some data set. So we're going to use one of the data sets we have in our LMS canvas. If you go into the LMS and get our data set called data_ptk for ptk in Spanish, .xlsx, it's an Excel file, right? We're going to use this data set for this demo, this video lesson. So we're going to grab that bit of code. Let's jump over to our old friend RStudio and let's get it loaded up. We got tidyverse and we got read XL on line 2. We're going to read in our ptk data frame. If we take a glimpse at it, let me make this a little bigger down at the bottom part of my screen. Right, the glimpse gives you some summary information about the data set. There are over 1,500 rows, 39 columns. Here are the column names and their data type. Cool. The head gives you the first n number of rows. I think it's 6 is what head does. If you just simply ask to look at it, because it's a tibble, it'll give you the top 10 rows as we've seen. Anyway, so this is the data set for a paper that I did a couple years back, looking at ptk, the voice onset time of ptk. I'm using those sounds on purpose rather than saying ptk because it could be some other orthographic symbol, letter. Among English speakers, Spanish speakers, and early bilinguals of English and Spanish. Okay, that's cool. Let's go back here. So the base function is gglot2 or ggplot without the 2. For whatever reason, the package name has a 2, but the function does not. So this creates an empty palette or window. So if we jump back to here and we just type gglot2 or ggplot, I keep saying 2. On the bottom right of my screen, it popped up in the bottom quadrant here where I'm sitting. It popped up just a blank palette. If I zoom in on it and then pull it over to the screen that you're looking at, if I can get it here we are. Here it is, just an empty palette. Cool, not very useful yet, but that's useful just to know that that's what you can do. The first argument to ggplot function is a data frame. So you can either pass in the data frame like that as an argument, or you can use our new friend or old friend, the pipe. This is the base R pipe, right? So if we jump back over here, if I wanted to, I could do ptk, pipe it into ggplot function. Good, same result, nothing really has happened yet. Okay. The second argument to ggplot is a call to the aesthetic function, AES function, short for aesthetics, which maps columns in the data frame to elements on the plot. So the first argument to aesthetics is what will be the x-axis on a plot, and a second argument, if needed, will be plotted as the y-axis on the plot. So let's just do that. We grab this, and good. So on the x-axis, it's kind of hard to see because I'm in the way. Let me go back to this view. Here's the kind of zoomed in view a bit right here. So I asked for it to take lang, which was one of the columns in my data frame, my ptk data frame, and I have 2 levels. I have English and Spanish, ENG and SPAN. Good, so it did that. Thank you, ggplot. Very nice. Or we could do it on the y-axis, right? If we were to take this little bit of code, let me grab it like that and just do it here, right? I have 5 levels in the column called pre-fon bin. The previous phonological sound binned up into bins. I have _son for sonorant, pauses, obstruents, non-high vowels, and high vowels. Again, we can look at it up here if we wanted to. So, good, making progress. So you can say x equals this or y equals that. The x-axis is the horizontal axis. The y-axis is the vertical one. So there you go. You can choose that whichever position you want it to be on. Wonderful. Let's keep rolling to actually something useful. Good. One categorical variable. Perhaps the most basic plot is of one categorical variable. In order to see the distribution of levels, the values or groups of a categorical variable, let's create a popular option, the good old-fashioned bar plot. Note the several layers of the plot are separated by the plus sign rather than the pipe operator. And the layers are often specified with the geom prefix, and so that's what we'll look at here. Let me go ahead and put this up here, hit that. Okay, so my line's 15 through 17 on the top left of my screen. I start with the data frame. I pipe it down with the base R pipe. Again, this could be the tidyverse coming from a gritter pipe if we wanted it to be. Either one works for this purpose. We have our gglot function. Within that, we have our AES, stands for aesthetic function. And on the x-axis, we want to put lang. And then we have a plus sign on the far right of my line 16. I think you can see that. And then we have a new function called geom_bar, open close parentheses. And we end up with what is on the bottom right of my screen, which looks like this. So we have English and Spanish, and we have slightly more Spanish tokens than English tokens. That's why the right bar here is slightly taller than the left bar. Simply giving number of tokens. Very simple plot. It might be good to get the exact number. We have used count in the past, so we can go ahead and use it right now. And if we put it into my lines 18 and 19 and run it, the bottom left of my screen gives the actual numbers of those bar plots. Cool. There we go. Very nice. Here's an activity. Take a look at the variety of bar plots that are available in ggplot. If you click on this, you can take a look at all the different bar plots they have. This is the doc page for bar plots at gglot2 package. If I just kind of skim down quickly, we should see some examples. Here's some examples. We have vertical bars, we have horizontal, right? This is a y-axis thing. There, they have y equals the variable name. You can do a filled bar plot here. So we have three variables going on. We have the class on the x-axis, we have the count on the y-axis, and then color. The color of the plot gives you a third variable, in this case drive. Their example is 4F and rear. This must be front wheel drive, rear wheel drive, and four-wheel drive, I think is what those are referring to there. But you can use colors to communicate another variable. You can do it horizontally if you like. Anyway, all sorts of plots. You can take a look at this. If you click on that link in my lesson plan, I'll link to my lesson plan in the description of the video. Okay, then using the data frame we've been working with, plot the distribution of several categorical variables. Here's some of the categorical variables, maybe all of them, in that data frame. Okay, so basically take some of my code in my lesson plan here that we've looked at, and just go ahead and plot up some of the categorical variables for a couple minutes here, just to get familiar with the syntax and what comes out in the plot. Ready, set, pause. Okay, welcome back. Let me just do a couple with you. If I come over here and change, let's see, on my line 16, if I change lang to, say, genre, and look at the result. So I have two genres, really registers. I have conversation and I have a reading. So the participants read, or I converse with them just spontaneously. Looking at the count there, it looks like we have a few more tokens from the conversation than the reading. Again, if we wanted to look at the exact numbers, we could ask our old friend count on line 19, 18, and 19 to give us the exact count of tokens of those bars right there. Okay, cool. Let's look at pre-fon bin. Previous phonological bin, binned up on my line 16, so my lines 15 through 17 will now create a new plot. There's a new plot, and we can look at the distributions. We have a lot more non-high vowels, the second bar, than we do high vowels, which is the first bar. And we have about the same number of obstruents and pauses and sonorants, a few more sonorants than the other two. Again, if we wanted to, we can get the exact numbers with our old friend counts, and they're the exact numbers that those bar plots are representing visually. Wonderful. Maybe one more. I don't know. Let's see. Previous mention. Let's try that. We slap in previous mention into my line 16, so we're running 15 through 17. Previous mention. So by and large, the word that pataka occurred in was not previously mentioned in the conversation or the reading. Here we have a larger bar for no, previous mention on the left, and a shorter bar for yes on the right. That is that the word in which pataka occurred had been previously mentioned in the recording. So again, if we wanted to, we can say, give me the exact numbers, please, on lines 18 and 19. And those are the exact numbers that those bars are representing. Wonderful. Okay, let's move on to two categorical variables. These are probably the most popular ones that I've seen for trying to represent two categorical variables. We have a stacked bar plot, a percent bar plot, a grouped bar plot, and then a mosaic plot. Okay, let's back up to stacked bar plot. To create a stacked or filled bar plot, we have one categorical variable as the x in the aesthetic function, and the other given as the fill argument in the aesthetic function. So for example, let's take a look at this bit of code. I'm going to grab for my lesson plan. My line's 20 through 22 right now. So we have our data frame called pataka. It's a variable called pataka. We pipe it down to our ggplot function. It gets piped into where my cursor is blinking right now on line 21. And then we use the aesthetic function. We say on the x-axis we want lang. We want you to fill, that is with colors, another variable called prefon bin. And then we use the plus sign on the right-hand side of my 21, line 21, the top left of my screen. And then we ask geombar to actually plot them up. And the bottom right of my screen, it comes up. I'll zoom in or expand that a bit here. Okay, so what do we see? We have on the x-axis, we have English and Spanish, the lang. And on the y-axis, we have just the counts. Good. And then we have a color dimension here, or color aesthetic, that is communicating more information. So we have in this kind of salmon color at the top, we have high vowels. And then in this like green, army color green, we have non-high vowels. And this another green, obstruents, and blue is pauses, and purple are sonorants, sounds. So you can see that there are, what do we see? We see that in Spanish, we have a larger group of non-high vowels in this kind of military green, army green type thing right there, than we do in English. But in English, we have a larger number of obstruents than we do in Spanish as the previous sound. Again, this is the previous sound before the pataka. Yeah, so we can see just kind of a distribution of the two categorical variables. We have language as one, either English or Spanish. We have the previous phonological context binned up into 5 bins, 5 categories as colors. There. Wonderful. Good. There are more examples. You can take a look at the docs here. If I click on this link, see more examples in the bar plots in the docs. I think this is what I just already showed you guys. Yes, it is. Okay, we're ready to roll. Let's keep moving. Follow-up questions. How can you get the exact number of tokens in each of the subgroups displayed in the plot? So let's jump back to RStudio. What I'm asking is, how can we get the exact number of, say, high vowels in English, and the exact number of high vowels in Spanish, and then the exact number of non-high vowels in English, and then Spanish, et cetera, et cetera, et cetera, et cetera. How can we get those exact numbers? Right? We can use our old friend count like we did above and just throw in the other variable. So let me grab my little bit of code. There it is. Bingo. On my line 23 and 24, top left of my screen, I can just say, hey, here's a data frame, pipe it down to count as the first argument where my cursor is currently blinking. And then count up the language, count up the number of tokens per language and per prefon bin, previous phonological bin. And so, yeah, down at the bottom left of my screen, we see we have three columns. We have a tibble or data frame, with 3 columns. We have language, pre-fund bin, and then n is the number of tokens. So apparently in English, we have 114 high vowels. So to jump back over here, let me just put this over to the side a bit. The top left of my plot here, that salmon in English is 114 tokens apparently. And then over in Spanish, line 6 of my data frame, in Spanish, the non-high vowels, there's only 49. So if you look at that, okay, yeah, it makes sense because on the top right of this plot, that salmon colored in Spanish is shorter, right, than this one in English. So anyway, that's how you can get the exact numbers of those various regions in the plot, if you like them. Okay, wonderful. Pretty straightforward, right? Very little code that we as humans have to write. Very easy to use. Percent bar plot. So to create a percent bar plot, that is a stacked bar plot that sums to 1.0, let's modify the previous bar plot by adding the argument position equals fill to the geom bar. So let's just grab our code for my lesson plan. So my line is 25 through 27. In the top left of my screen does it. So let me just expand out. The previous one for my lines 20 through 22 is what we're seeing on the bottom right of my screen. This one, okay? All we have to do is add position equal fill to our geom underscore bar function. And when we do that, it modifies the plot so that now on the y-axis, it goes from 0.00 up to 1.00. So it sums to 1, that is 100%. And so I don't know if you noticed the previous one, they weren't, let me just go back to the previous one. I just ran my lines 20 through 22. You can see these bars aren't the same exact height. They're close, but they're not the exact same height. And the y-axis is giving the raw count, like just how many tokens there are. Whereas with this percent one, I just ran my lines 25 through 27. They both add up to 1.0, and you can see the percentage in each language of how many, what percentage, that is, not how many tokens, but what percent of the total number of tokens in the language come from each of these 5 levels in the categorical variable pre-fond bin. Okay, so again, I just simply added position equals fill to the geom bar function there. Pretty simple, right? Very little code for a pretty cool plot. We noticed that the y-axis is labeled count, but those aren't counts. Oh yeah, let's go back here. So yeah, you can see that says count. That's actually not counts. Those are percentage, or it's ratio really. A ratio, proportions. We can change that with the labs element. So let me grab my code. I'm going to copy my code from my lesson plan and go over to RStudio and slap it in, paste it in. So my lines 28 through 31 now do something more. We have on 28, we have our data frame, put to k. We have a pipe. And then on 29, we have ggplot with the aesthetic. And then on the x-axis, we want lang. We want to fill with pre-fund bin, that is create colors. And then on 30, let me point out real quick, on 29, we have a plus sign. And then on 30, we're going to use geom bar. We're going to say position equals fill to do percentages to make it add up to 1.0. And then we have a plus sign on the right-hand side of my 30. Don't miss the plus sign there. Again, I just want to point out, on 28, we have a data frame, and we use the pipe, either a base R pipe or a tidyverse pipe. We pipe it into ggplot function, and then once we're in the ggplot area of this pipeline, we're going to use plus signs for each layer. A little confusing. Don't let that throw you off. And then there's a labs for labels function, and we can say on the x-axis put language spelled out rather than just L-A-N-G, which the default right now is L-A-N-G. That's the name of the column itself. But we can say change that to languages for the x-axis label, and the y put proportion. So if we run this, when my cursor is blinking anywhere in the pipeline, I can just run it, Control Enter on the keyboard or Command Enter on Mac. The result is that it changed the labels. So on the y-axis we have proportion. On the x we have language. The bar plots themselves haven't changed, but just the labels. So we added a new layer to this plot with labels. Cool. Nice. Okay, grouped bar plot. To create a grouped bar plot, we modify the previous bar plot by changing the argument to position equals dodge. Simple enough. Let's jump back. So I just copied my code there in my lesson plan. I'll come back over to my RStudio. So my lines 32 through 34 now do this. And now we have what's called a grouped bar plot rather than a stacked or a percentage bar plot. So we have the same info. We have the language on the x-axis. We have the count on the y-axis. We still have colors representing different levels of the pre-fun bin, the previous phonological context binned up into separate bins. But now we can, they've grouped them into separate freestanding bars there. Same information, just kind of presented in a different way. Just to be clear, this information we're seeing right here is the same as we had right, not quite that one, what we had right here, this one. It's the same information. This is a stacked bar plot, whereas what we have down here is called a grouped bar plot. Same idea, trying to give just convey the distribution of levels within a categorical variable. Okay, that's a grouped bar plot. Mosaic plot. Another useful plot for two categorical variables is what's called a mosaic plot, which displays proportions as relative sizes of the various pieces of the mosaic. A mosaic, as you may remember, is like a window with different sized pieces, right? Or not a window, but like it could be like a piece of art. Anyway, let's download an R package that can be used to create mosaic plots. VCD stands for Visualizing Categorical Data. So let's just go over to RStudio, go down to my console in the bottom left and do install.packages. RStudio senses what I'm doing. I say, sure, I'll accept that hint with tab on my keyboard. Double quote VCD for Visualizing Categorical Data. Bingo. Very quick download, not a big file. Wonderful. And I have quite a bit of code here, but let's just take a look. Let's grab our code and put it into our studio here. So the first thing is we got to pull in VCD, right, with the library function. Now I'm going to take patuka, I'm going to pipe it down to count onto languages and prefun bin. Then once I do that, I'm going to pipe it down to, on 38, I'm going to pipe it down to 39, where I use pivot wider, a function we saw recently, right? Pivot wider, and I'm going to say the names come from the prefun bin, the values come from n. And when I do that, I'll just run 37 through 39. If I take a look, if I put my cursor down in the bottom left of my screen and do temp, what I have is I just kind of pivoted it wider like this. I have language. Then I have the 5 levels of the prefun bin, and then there are counts in each of those 2 languages. Okay, wonderful. Now I'm going to, on 40, I'm going to run this little code, line of code to just pull out those as row names. I pulled out column 1. Temp, pipe to pull, means pull out one of the columns. I wanted to pull out column 1. I'm going to take temp and change it to what's called a matrix. Under the hood, what we're going to do next needs a matrix rather than a data frame. So it still has the same info if we just look at it. Same info, but in this case, lang has changed a bit. But okay. And then we're going to get rid of that first column by saying temp, square bracket, comma, -1. If we look at it now, we don't have that lang column that we had a second ago right there. This is now gone. We just have those 5 left. Good, then we're going to slap on the row names. So if we look at temp now, the English and Spanish are what are called row names. They're not actually a column anymore. They're something else called row names. Now, finally in 44, so all that was just kind of prep work to get the data into the format that this function requires it to be in to use it. So if we ask the VCD package, Visualizing Categorical Data package, to use its mosaic function, we pass in our matrix, and if we just let this go, we'll see the result. Let me zoom in so we can look at it up here in a bigger format. Okay, so this is called mosaic plot. Again, it's kind of trying to mimic a mosaic, a piece of art with different size pieces, right? So the top row is English. It says ENG right there, English. These are English tokens. The bottom row is Spanish tokens. And then we can see the columns are labeled above, so high vowels, non-high vowels, obstruents, pauses, and sonorants. Okay, so the first column, so to speak, on the left is high vowels. The second piece of the mosaic on each of the rows is the non-high vowels. The third is our obstruents, etc. It also is kind of cool. It does a little bit of inferential stats for you on the fly. And it tells you which levels are occurring more often or less often than expected. So let's look at the top here. English non-high vowels, because it's a dark red, it's a negative person residual value, which means that English has fewer non-high vowels than would be expected. Whereas Spanish, with this big blue part right here in the bottom row, second from left, has many more tokens of non-high vowels in Spanish than would be expected. So the colors mean something as well as their sizes. So that's how you do that. Also, the height of each row is proportional to how many tokens are in each of the languages. Because they're so close together, we can't really tell that those are different heights. But so that's called a mosaic plot. All right, your turn. Let's give it a whirl. You guys give it a whirl. Using the Pawtucket data set, plot the distribution of sets of two categorical variables. For example, if you want to do language and genre, or previous phonological bin and following phonological bin, or previous mention and cognate status, or others. Okay? So I'm going to ask you to pause the video and give it a whirl. Give it a shot. See if you can plot up two categorical variables using the Pawtucket data set. You can use these ones I have here on my lesson plan if you like. Ready, set, pause the video. All righty. Let's do a couple together real quick. Let's do Pawtucket, pipe down to gglot2, the aesthetic. On the X, I'm going to put, say, lang. And on the Y, I'll put genre. We're going to do a plus sign there. We're going to do geom bar, open close parentheses. Okay. Murphy's Law just hit. What did I do wrong there, folks? Oh, I see why. Okay. Right, rather than Y, we actually want to do fill right there. Right. So here on the bottom, right on my screen, let me actually put it up here and bigger. What do we see here? On the x-axis, we have language, Spanish and English, English, Spanish. And on the Y, we have the count. And in colors, we have conversation. CONV stands for conversation. And the genre, that's the salmon color. And then the teal is reading, the reading passage that they did. Okay, that's mildly interesting. Cool. How about pre-fawn bin? And then we do fall fawn bin. You can see our students help me out and say, sure, tab, I'll accept that suggestion. Good. There we go. We have 3 levels in the following phonological bin in colors, and we have 5 levels in the previous phonological bin on the x-axis, and on the y we have counts. All right, we could change this if we could say, let's do position equal dodge. Position equal dodge. What does that do for us? Okay, it turns it into a dodged or a grouped bar plot. We can see by and large that there are many more non-high vowels than other following sounds. The green here are non-high vowels that follow the Pawtucket. And then on the x-axis, we have the previous sound before the Pawtucket. High vowels, non-high vowels, etc. Obstruents, pauses. Cool. There we have it. Hopefully that was a useful activity for you to get your hands metaphorically dirty with some categorical variables. All right, let's keep rolling here. One continuous variable. It can be useful to visualize the distribution of continuous variables in order to see whether the variable is distributed normally or has some skew or is bimodal. All right, so the following plots are useful for this purpose. You only need to specify the x argument into the aesthetic function within the ggplot function. So the histogram is probably the workhorse of plotting continuous variables, just one continuous variable, the histogram. And it's super useful to do so, and it's super easy to do so. Let's take a look at my lines 49 through 51 on the top left of my screen. So I'm taking putk, and I'm using ggplot, the function, the aesthetic within it, x equals VOT. So VOT is a numeric or continuous function. And then we use the plus sign on the right-hand side of 50. Geom underscore histogram. We run this pipe. If I have my cursor blinking anywhere in that pipeline and do Command Enter on a Mac or Control Enter. Bottom right of my screen has the plot. Let me make it bigger for us. By the way, I'm simply clicking on that, zoom, and then just kind of going back over here to look at it. So here we have it. We have a histogram. So on the x-axis, we have VOT, which is voice onset time in seconds. These numbers are seconds. How long did it take from the release of the putk to the start of voicing of the next vowel or next consonant? Probably vowel. Yeah. And then here on the y-axis, we have the counts. Just number of tokens within those bins. So we have, it's kind of like a bar plot here. And it just chooses the number of bars that it feels is best. I think the default might be 30. It probably just depends on what the number of tokens, but you can specify the number of bins. If you want to have a certain number of bins, you can say bins equals that number within the geom underscore histogram. So if we do that, you can see that we now have fewer bins, fewer columns there in this histogram. You know, we could bump this up to something larger. I think 30 might be the default. We can do something even larger if we felt the need to. There's 50. What would like 100 be? That'd probably be not super useful. Yeah, I'm not sure 100 is useful. The default is usually great. It says right there, it's using 30 bins down at the bottom left of my screen. Cool. Okay, wonderful. Also, instead of the number of bins, like the number of bars, you can specify the width of each bin on the scale of the variable that you're plotting, the x-axis scale. This is useful because the bin width is often more meaningful than the simple number of bins. So let's actually do that. Let's create a bin width of 0.01, which is 0.01 seconds or 10 milliseconds. We can do that with the argument bin width in that same, let me just recreate what I just deleted real quick. Bins equals 10. So on my line 54, I'm saying bins equals 10, meaning give me 10 bins. But on line 57, from 55 down to 57, I'm saying I want you to use whatever number of bins you need, but I want at most a 0.1 width of the bin. That is 0.1 seconds or 10 milliseconds. We run that, then we get this version of the histogram now. It looks a little different, but kind of the same basic structure, shape, but a little bit different view of the data. Okay, that was bin width. If we want to do something bigger, let's say 20 milliseconds, what do we get for that? That does that. If we do a little bit smaller, let's say like 5 milliseconds, we get that structure. So you can specify the bin width or the number of bins with the histogram with ggplot. Okay, so that's histogram, one of the big workhorses in visualizing a single continuous, that is numeric variable. Density plots are also super useful. You'll see these a lot. These are very much like histograms, but they have a curved line rather than bins, or like columns. Let's take a look. Let's use that same variable, VOT, which is voice onset time, of our putk. We run it, and we get this line. The structure looks very much like what we saw with the histogram with the actual bars, like the columns. but it's a curved line. That's what that does. All right. Okay. We can fill it in with a different color if we like. We can add fill equals, for example, blue into the geom density function. We get a blue there. Obviously, you can change this to something else if you want red, bingo, etc. If that's useful. Okay. Give it a go. Your turn. Time to step up. Plot the distribution of several different continuous variables in the particular data set and be ready to share with a neighbor or with the class. Okay, so just take a look at the data frame and figure out which variables are continuous. I'll tell you right now, VOT is. COG stands for center of gravity. COG, capital COG is also another one. Why don't you give that a try? Okay, go ahead and pause the video and give that a try. Ready, set, pause. Alrighty, let's go take a look. If I were to put in, say, COG here on my line 62, rerun that pipe from 61 down to 63, I get a histogram, or not a histogram, but a density plot of COG, center of gravity. So center of gravity is an acoustic measure of the average frequency in hertz of a sibilant sound. And so the higher the COG, the more robust or like more fricative the sound is. Like a s has a high COG, whereas like has a low COG. Just give some context on the COG. Cool. We could do a histogram if we wanted, right? We could change this to histogram, take off the fill. Oh, I guess the fill would probably still work. Yeah, we can fill columns like that if we wanted to. We could say, well, give me only 10 bins, please. Okay, that's useful. How about bin width? Give me a bin width of 10 milliseconds, which is 0.01 seconds. That's not super. Oh, these aren't seconds. Sorry, this is a different scale. COG is a different scale. How about say 1,000 hertz? Oh, that was not useful whatsoever. Anyway, you get the idea that there's all sorts of customization you can do with gglot2 package. Okay, let's keep rolling here. Okay, with two continuous variables, the mighty scatter plot is the go-to plot for two continuous variables. That is numeric variables that have numbers, right? Let's take a look at Dr. Joey Stanley's vowels, literally his vowels that he recorded himself saying, and looking at formants in those vowels. I express thanks to him for making his data and expertise available with this data set and his pages. He has a great website. You can link to. I have been linked to there. So the first thing I'm going to do is download a package that allows us to download packages from GitHub. It's called remotes, and so I'll grab this little bit of code, install packages, remotes. I'll grab that little bit of code, jump over to RStudio, down on my console. We're going to do this. I've already done so, but I'll just do it again. Hopefully this won't cause any problems. Okay, good. And then let's load a data set called coronals, and with this little bit of code. So within the Joey's vowels package that we just downloaded from GitHub, which is a website, right? We can share software and data. There's one called coronals. We'll save it as midpoints. Save it to a variable called midpoints. Let's just put this up here now. We already have tidyverse. So we're going to do midpoints my 65. We're going to do save a new variable called midpoints. Joey's vowels, coronals, good. Take a look at, no, sorry, 1 second. I do need to actually get tidyverse in here real quick. Tidyverse. Okay. Let's see, glimpse, yeah. So we can look at the package or the data frame. We have over 14,000 rows. We have 13 columns. These are the column names. So the val ID is the specific val. It's a unique identifier. The start time, the end time, and the time at which each of the formants is taken. So the percent might be easier to look at this way if we do it this way. Yeah, 14,000 rows, 13 columns. The time here, T, is the time stamp at which these formant values were taken. So 0% into that val, that is right at the onset of the val, the T column is the same time as that. 5% into the val, we have these formant numbers, and that timestamp is that number. So that T is the timestamp. The percent is how far into the val these measurements were taken. So 0% is right at the onset. 50% right here is right at the midpoint. And these values here for F1, F2, and F3, and F4, right? F1 is the first formant. It's the second harmonic of a sound in the mouth, right? Where there's more resonance or where there's frequency, the sound resonates. F2, F3, and F4, these are the formants or resonances. Harmonics is what they're technically called. Okay, cool. And we can take a look at this up top if we wanted to. We can go, give me the midpoints, pipe it to the view function at the very top of my screen, top left. We can see this in a spreadsheet-like view. We have the previous sound. We have the vowel represented by a word. We have O, right? And we use the word goat to represent O. And then we have the following sound. So the word is snooze, written in IPA, International Phonetic Alphabet. Anyway, that's that data set. This is the data set we'll use now to look at continuous variables. Let's go ahead and use only the middle point. So we only want percentage to be 50%. So we're going to take the middle measurements. Again, there are actually quite a few measurements taken on each vowel. We just want to grab the middle measurement, the 50 percentile measurement, so to speak. So we'll do that. We'll do filter equals percent, double equals sign 50. We'll pipe that down to select and get rid of percent after using it. And then we'll only look at a few vowels here for the moment. We'll get rid of these few vowels. So if we take this bit of code in my lesson plan, jump over to here, go back to my script file. So my lines 68 through 71 now do what we just described. If you have your cursor blinking anywhere, then it'll run the whole pipe. So if we look at it again, if I type down on my console bottom left of my screen, midpoints, then we should only have middle, the median of the vowel measurements. Yeah, so we only have unique observations of vowels now. Okay, so we have the formants here, wonderful. This is all looking good. Wonderful. Let's keep rolling. So let's plot the first two formants of his vowels. In vowel plots, the norm is to plot F2 on the x-axis because it deals with the vowel backness, like how far back in your mouth it is, the depth in the mouth. And F1 on the y-axis because it deals with vowel height. Okay, so let's do that with this code right in the middle of my screen right now. Copied it to my clipboard. Going to jump over here on line 72. We're going to paste it. So line 72, top left of my screen down to 74 should do this. Okay, good. So again, let me make this bigger. Where is my, I need to zoom in, pull it over here to this screen right there. Wonderful. Let's make it a lot bigger for us. Okay, so here we have on the x-axis, we have F2, which is formant 2. On the y, we have F1, formant 1, right? Because F2 deals with backness or depth in the mouth, and F1 deals with height. Wonderful. There are his vowels from this data set. Okay, not super useful just yet because we don't know what vowel was said. But also, as is the practice with vowel plots, usually you reverse the scales. So we can use these little functions, little helper functions or layers in the plot to reverse the scales. So my lines 78 and 79 of my script file on the top left of my screen reverse the scales so that we end up with this type of plot. So on the y-axis, we have at the very top, we have 200 hertz down to 700 hertz. If you can see that right there, 200 down to 700 or below or higher than 700. And on the x-axis, we have formant 2. We have 2,000, tick mark of 2,000 right there, down to a tick mark of 1,000 hertz. These are hertz, right? Hertz is the number of cycles of a sound in a second. Number of waves, number of peaks, you might say, in a wave form. This is not a phonetics class, but That's what that refers to. Wonderful, that's nice and all, but how about knowing which dot corresponds to which vowel, right? So what we can do is we can add in a color on the vowel. So there's a column called vowel, and it's actually a word that's representing the vowel. So the only thing I've changed from the previous step is this right here, color vowel. We take a look at that. What do we see? Well, we have some colors now for each of these vowels on the right-hand side. Let me make this a bit bigger. Okay, so we have quite a few vowels. We have, what, 10 plus vowels, 10, 12 vowels in there in this legend on the right-hand side of this plot. And the colors represent the vowels. So, ah, as in lot, ah, as in trap, is this color. A, as in face, is this color. So what do we see here? On the top front high position in his mouth, we have A, face. We have this color here, fleece, E, ease, right? E is the vowel. Fleece is the word that represents that vowel. Unsurprisingly, that color, it's kind of like a teal color up here high. Yep, front high vowel, that's where that vowel should be. We have I in kit. It's this kind of darker teal or turquoise color right there. Wonderful. How about this blue? O, goat. Yeah, it's in the back part of his mouth. What's this down here? This is aw, as in lot. Yep, low central or low back vowel. This all makes sense to me. It's not like a super well formed triangle, but it's very much triangular shape. Cool. There we have it. Wonderful. The background is actually gray. Let me jump back. The background here is gray, so it can make it a bit hard to distinguish the colors. We can change that by using another layer called theme_BW for black and white. So if we can go here. So my line's 85 through 90 now. Should create a white background. Yep, we have a white background now. And that might be a little bit easier to distinguish the different colors without the gray behind it. Again, we just added this one layer called theme_BW for black and white. There are quite a few there, like minimal is another one that I like. Let me show you what that is. It's basically black and white without the outer border. Anyway, won't take too much time right now for that. But also, if the publication you're going to use or you're going to submit to, like a journal, for example, doesn't support color, you can use shapes rather than colors. And so rather than color equals vowel, you can say shape equals vowel. So let's try that. And if we run that, now we have shapes. Now, the number of vowels we have here causes some of these vowels to not be represented by any shape. So on the right-hand side of my plot, the legend right at the bottom, we're just missing these vowels. They're just not plotted because there aren't enough different shapes. So that's a problem, right? That gives you 6 shapes by default. So you can use a color. We can also filter. If we just want to look at these few vowels, let's just filter for a moment. Let's use our old friend filter as one of the kind of steps in the pipeline before we get into the ggplot there. And if we do that and run this, let's take a look. So what we have here is we have lot and thought. That was awe and awe, a thought. Joey's from St. Louis, and so he distinguishes some vowels that I don't personally. But you can have both color and shape. We have color equals vowel and shape equals vowel. So we're actually using both colors and shapes here in this particular plot. We have dots for lot and orange dots for lots and for lot and teal triangles for thought. So there you go. Again, we just added those into the aesthetic within the ggplot function there. Wonderful. We can add more information to the plot with the diameter and opacity of the dots. Usually it makes sense to vary the diameter or opacity of the dots with a continuous variable. So let's make a continuous variable of duration of the vowel within our pipeline before passing our data frame into the ggplot, and then specify with the size argument that the diameter of the plot should be proportional to the duration of the vowels. So here we're going to create a new column in our data frame called duration. And we're going to say, give me the end timestamp minus the start timestamp, and that'll give us duration, right? And then we're going to use that variable we just created down here as the size of the dots. So let's use this, throw it in here, run that. So my line's 104 through 110, do that. And if we look at the result, let's go back to here. So the duration is proportional to the size of the dot. And we see that information on the bottom right of the plot now. It gives you the relative sizes. So the smaller the dot, the shorter the duration, the larger the dot, the longer the duration of the val was. Cool. Yeah, that's interesting. You can see different durations. So we actually have 4 pieces of information for each val. On the x-axis, we have format 2, F2. On the y-axis, we have format 1, F1. And then the color tells us which val it was, a categorical variable. And then the size, the diameter of the dot tells us the duration. So it's kind of hard to see because they're pretty similar to each other, but you can maybe see that this green dot where my cursor is circling right now is a little bit less far across. The circle is smaller than, say, the one next to it right there. It's a little wider. This is very wide down here. Okay, cool. That's nice, but the overplotting, that is the dots that are on top of each other, makes it hard to tell exactly where the dots are. And so what we can do is we can use a bit of transparency so that the dots that are on top of each other, we can kind of see a bit. And that can be done with the alpha argument into the aesthetic. So rather than size, we can do alpha. And let's take a look at that. I just copied that bit of code from my lesson plan. I pasted it between 111 and 117. Run that pipe. And so now we see that there's a bit of transparency. Rather than size, the bottom right of my plot now says the duration is being mapped to transparency. So the more transparent, the shorter the duration was, the more solid, the longer the duration was. That's another way to put this column onto the plot, this information onto the plot. Okay. We can also plot the duration of the vowels as sizes of the dots. So let's try that. My 118 through 124. Now we just did that. Okay, that's good. If the sizes of the dots are too big, we can constrain the range of their sizes with this right here. So it says scale, size, continuous. We only want to constrain it between 3 and 0.5. Right, that. If we throw this in, now we have, we can reverse the order to make, if we wanted to, make the shorter vowels have bigger dots and the longer vowels have smaller dots. All sorts of customization you can do here. This particular function is another layer that we added on. You can take a look at the help page on that, right? A little pop quiz. How do you look at a functions help page? You can do a question mark in the name of the function. That's not it. If we do question mark, this is scale, size, continuous on the bottom right of my screen. I get the docs. If I click on this little expander button, it'll bring it up into a bigger window. Let me grab it from the other screen that you're not seeing currently. Here it is. Size, scale is the area for radius. You can take a look at the documentation there. And for range specifically, right? There's a range argument there. You can read about what that does. Okay, good. Now, that's cool. Regression lines. This is an important idea with scatter plots. You can see points, sometimes you can see general trends, but a regression line just shows you exactly what the general trend is. Okay. And if you want to see how one continuous variable affects the other, the regression line, also called a trend line, for example, in Excel, I think they use the word trend line, is useful. It's a straight line that shows the overall trend through the data points. This is done with another layer on the plot and we can use this. The LM as a linear model or linear function. So let's actually jump back to another data set, our previous data set, PTK, PTK, and let's map, let's see the effect of COG on VOT. And then we're gonna do points, we're gonna plot points, then we're gonna use a regression line here, method equals LM for linear model, which is regression, and let's make it black and white. Let's try that and take a look. And if I have PTK loaded up, I should see, that's not what I want this other one, here it is. So that blue line there with the 95% confidence interval in gray around it shows me that, yeah, as COG increases, that is as the frication, the robustness of the frication of the sound between the release of the stop and the start of voicing of the next vowel or consonant, that the amount of frication there increases, the VOT, the amount of time of that space increases as well. It's a positive relationship. We have the more, right? The more on the X, the more on the Y. That's why that blue line is sloped positively from left to right. Okay, that's a regression line. The low S line is another cool line. This is another option to show the general trend through data points of two continuous variables. It's called low S. Low S, what does that stand for again? It's local, what does that low S stand for? Locally estimated scatter point smoothing. No, that's not the acronym. Anyway, it does a locally based smoother line is the way I would say it. Locally based smoother line. Shows a local trend through the data points. So rather than method equals LM like we did before, we'll do low S. So if we look at this one here, again, we're seeing the blue line. It's a low S line. You can see that by and large it increases, but out here on the far right it kind of plateaus and becomes flat out here. So that's useful. Like down here on the left hand side, yeah, the more COG, the more VOT, but out on the far right it just basically there's no effect. It's pretty level. That's a low S line. Good. I just kind of explained that in my own words. Of course, you can put both the regression line and a low S line on the same plot. If you do so, I'd encourage you to use some other color besides blue. The default is blue. I'm going to use the default of blue for the regression line, which is straight. I'm going to use red for the low S line. I'm going to take off the standard error, the confidence interval, standard error bands, which were the 95% confidence intervals around the lines. What we end up with here is a regression line in blue with the confidence interval standard error around the regression line, the little gray bands. And then we have a red low S line with no standard error band around it. Cool. We're seeing that there's a positive relationship between COG and VOT, but that it kind of peters off at the far right once we have really high COGs. Okay, I think we'll call that a video. Actually, no, one more. This one's useful as well, super useful. They all are useful, but we got to look at these plots here. What do you do when you have one continuous variable and one categorical variable? What do you do? This is another common situation where you want to plot up the effect of one variable that is categorical, say, on the other variable that is continuous. The go-to plot in my mind is the box plot, also called the box and whisker plot, for example, in Excel. So let's jump back over to Joey's vowels, which we should still have loaded up in our session. But to make it more manageable for pedagogical purposes, let's filter out some of the vowels. So we're only dealing with 5 vowels. Okay, so we're going to use this little bit of code here to filter out only 5 vowels. So we're going to use our midpoints from Joey's vowels. We're going to filter on the vowels so that we're only using these 5 particular vowels. And then we're going to create a new variable called duration that has the duration of the vowel. We're going to save it to a new data frame called front_durs, duration of front vowels. That's what I've done on my lines 150 to 153. If we look at front durs there, just down the console, this is what we end up with, basically just a filtered version of the bigger data frame we were using previously, and we only have those specific five vowels: face, trap, kit, fleece, and dress. Those are front vowels. Okay, so let's take a box plot. We're going to do on the x-axis the val, which is categorical, and on the y we're going to have duration. And then we're going to pipe that down, or not pipe it down, but pass it down to another layer called geom_box_plot. And we'll use our new friend theme black and white to make it black and white, the background. So on my line 153 to 156, if I run that, you can see that I have a box plot. And I have the 5 vowels across the x-axis here. And then on the y-axis, I have duration in seconds. You can see that the dress is shorter, has lower duration than these other ones. Well, both dress and kit have a shorter duration in comparison to the other 3. And that trap, the a vowel, is longest among these 5 vowels that we plotted here because it has the highest box. Let me just explain that. The box is the middle 50%, and that horizontal line within the box is the median point. So we have the first quartile, the 25th percentile, the median, which is the 50th percentile, and the third quartile, which is the 75th percentile. And then these whiskers, what are called whiskers, that go above and below the boxes, go out 1.5 times the interquartile range. That's just a little bit of math to show how much more data points you have up there. That's all Greek. Don't sweat it for the moment. But a little bit of math to get the height and length of these whiskers. And any outliers beyond the whiskers are just plotted directly as dots, like that. So we have 3 outliers in this plot in dots. Okay, good. They're useful. Here's my explanation of what I just said. And yeah, the middle 50%, cool. Yeah, the interquartile range is simply quartile 3 minus quartile 1, and the upper whisker extends 1.5 times the interquartile range above the third quartile. Okay. It also can be useful to put in the mean. Like I mentioned a second ago, that horizontal line in the box is the median. But if you want the mean, we can put it in with another layer called stat summary, function y equals mean. If we do that, we can use the shape 4, which represents the cross or an x. So the x's here on these boxes are the mean there. So we have both the median and the mean. So the median, once again, is the horizontal line in the middle of within the box. The cross or the x is the mean. And then we have the first quartile, third quartile, that is the 25th percentile, 75th percentile. So we have the middle 50% of the data points within the box. And we have whiskers and outliers if there are any outliers. Okay, this is a super informative plot. This is way better than a box plot, or excuse me, than a bar plot. The box plot is way better than the bar plot. If you have to choose one or the other, I would recommend, if you can, use a box plot. Again, the idea with a box plot is you have one variable that is categorical. In this case, it's val on the x-axis. And you have one variable that is continuous, in this case, duration on the y-axis. By the way, I could totally switch these. If I wanted to say, hey, I want you to use, I want you to flip those. If I say actually put the duration on the x and the val on the y, it should be that simple to flip this 90 degrees to the side like that. Same information, but flipped on its side. I think I'll just stick with what we had what I have in the lesson plan, like this. Okay. Wonderful. Oh yeah, one quick thing here. With box plots, you can put a notch on the boxes with a notch equals true within the geom box plot function. Let me show you what that does. This is useful as well. It puts little notches on the sides of the box, and this is kind of preliminary evidence to understand or know if there is a significant difference between the boxes in the box plot, that is between the levels in the categorical variable. So for example, the fact that here trap, this notch right here where I'm circling my cursor right now, does not overlap vertically with this notch in the face val, the face box right here, is kind of evidence that they're likely significantly different from each other. And then if we look at, for example, the middle of these 5 boxes, this dress val, its notch clearly does not overlap vertically with these other 3, the 3 that are higher up. But it does overlap with the notch in the kit val, the far right box. So it's likely that dress and kit are not significantly different from each other, but that those 2 vowels are significantly different from the other 3 that are higher up based on those notches. Now, you should really do a real analysis, for example, in ANOVA, which this is kind of jumping ahead a bit, but we'll look at ANOVAs when we get to inferential stats and for reals. But here's just a quick ANOVA, just to show you a quick ANOVA, to show you, yeah, okay, there is a significant difference between these five categories. If we look at the 2-key honest significance differences, comparison of means, we do see, let me make this a little bigger. Where on the far right, we have p-values that are comparing each of those boxes in turn. So let me bring back our box plot. So trap and face. So these first 2 boxes, face and trap, when they're compared, they are not significantly different from each other. Okay, they are not different from each other, even though I thought they might be because they weren't overlapping, but apparently that's not the case. Dress and trap, let's go back to the plot. So trap is the first box, dress is the middle of the 5 right there. And as I suspected, the p-value below 0.05 says, yeah, there is a significant difference between those 2 categories, meaning the duration of A vowels is significantly different from the duration of dress vowels of A. Anyway, that's what these pairwise comparisons are doing within ANOVA. And let's see dress and kit. Dress and kit, right down here. Yeah, dress and kit, the p-value there, 0.935 is well above 0.05, and so we can say, oh yeah, dress, the middle box, and kit, the far right box. Let me pull it over here for a second. Far right box, the fact that these notches clearly overlap means it was confirmed within ANOVA that they are not significantly different from each other. Okay, I think we'll call it there for this video. I would encourage you to take time to mess around with my code, try different scenarios, different variables, and see if you can make these functions work. That I would encourage you to spend 5 to 10 minutes to just kind of review my lesson plan, making it work, changing up the variables, maybe changing up these vowels, creating a plot, see what you get. Okay, so that is what I would encourage you to do, is to make it work on your end if you haven't been doing so along the way. Great, thanks for watching. See you next time.